So in this question, what we have is a traditional Z transformation. Let's go to white. We have a traditional Z transformation where we're going to look at some observation minus mu over sigma. If we look, if we follow the old adage, when in doubt, draw it out, then we have a normal distribution of some sort with mean in the middle and then some standard deviations thereof. And we know how to draw these, so let's just talk about this real quick. All right, a can of soda should have 12 ounces of liquid in the can. Well, that's our mu, right? That's what it's supposed to be. Previous research has measured it. The average of all the cans of soda in the world are 12 ounces. Okay, fine. Previous work has resulted in a population standard deviation of 1 ounce. So I know that sigma is equal to 1. I know that mu is equal to 12. What is the probability that a can of soda has less than 11.5 ounces? So let's focus on this phrase right here, the probability that. So we're asking the question, what is the probability that, or the other way around, the parentheses is on the inside, the probability that X, any can of soda, some can of soda at random is X, is less than 11.5 ounces. And here we should get some percentage, or in our case, we're not looking for a percentage, we're going to do some decimal, but that's fine. Whatever it is, that's what we're trying to figure out, okay? So let's use the probability that a can of soda is less than, let's use green for 11.5. But before we do that, we can go ahead and draw out our normal distribution because I know that standard deviation is 1, which would make this guy 12, which we know, this dude 13, 14, 15, right? Because we're adding 1 sigma, 1 sigma, 1 sigma. And over here, we're going with negative sigma, negative 2 sigma, technically negative 3 sigma over on the left, which would make this 11, 10, and 9. My X is at 11.5 ounces, so I'm going to be right in here somewhere, and I'm asking the question less than X, right? Less than X. Everything on the left-hand side. What is X? It's 11.5. So what is the probability that we are going to draw something at random from left? So the first thing I'm thinking is I know that my normal distribution can be divided down the middle. And so if this is 50%, then whatever's in green has to be less than 50%. Just kind of a little mental self-check there to make sure that what you get is reasonable. The next thing we do is we go ahead and do our Z transformation to make sure that that's exactly the case. Z is equal to my observation minus mu over sigma, which is the same as 11.5 minus 12 over 1. And so this is some fairly easy math. This is negative 0.5 over 1, which means that I end up with negative 0.5. When you do a Z-score or a Z transformation, I encourage you to use 2 decimal points, which will make sense, 2 decimals after, or 2 places after the decimal. All right. Now, in order to get the green space under the curve, so I know that this, if I go from here to a standard distribution, let me draw that out, a standard normal curve, which is not the same, which is 0, negative 1, negative 2, negative 3, is going to have some observation here, right? And it's not an X, it's a Z. And I know that if I take this guy through my Z transformation down to this guy, that my Z is negative 0.50. Now we can go to the tables. And lucky for us, I happen to have a table just kind of sitting here. So first, I'm going to use the left-hand side of this table because that's where the negative numbers are. But let me make it bigger so that we can use it down here. All right, so through the magic of filmmaking, I've turned around and just grabbed the one file that we need. And we are looking for a Z that is 0.050. So the first thing I'm going to do is I'm going to split these out. I don't know why we do them this way, but this is the way we do them. And we're going to split the Z-score, and I'm looking for this negative 0.50. You can see in the Z's on the left-hand column that I have negative numbers, and I'm looking for 0.5, which is right here. The first half of that is going to go here, and then I'm going to look at everything that is on that row all the way across, right? The second one, I'll do it in blue, is the 0 here. That guy's going to go here to the very first row, and it could be any of these, right? It could be any of these. It isn't in our case, it's just the 0. So I select this 0, and this is how we're going to build this out. So I'm going to walk down this 0 until I get to the 0.5, and it's going to tell me that this percentage is whatever the area of the curve is right of our x. Now this is important. This is important. In this graph, we have what's left of the curve, not what's right of the curve. My apologies there. And what it means is, and what I mean is, when you have some curvature, whatever the x is, the 0.30 represents, in this case 0.3085, represents the area left of x. Or in this case, the area left of z, really, the area left of z. Okay, so we have this curve, I'll do it again, we have this curve where we know we have 0 in the middle, and over here we have negative 0.50, and we're saying there is an area under the curve left of z, this is my z. What is the area under the curve? And the area under the curve, this orange that I'm graphing out here, is 0.3085. Okay? Noting that everything under the curve constitutes 100%, then this area here constitutes 30.85% of the population, because the entire population is covered under the curve from positive infinity to negative infinity, right? And that's what that number means. And that, frankly, because it is left, which is also less than, right? If it was greater than, we would be on this side, but we're not. Our question, if we go back to the beginning, asks us for less than, and so our answer is that the probability of drawing one can at random from that is going to have less than 11.5 ounces of soda is equal to 30.85%. A more statistically professional answer would be 0.3085, but they pretty much mean the same thing. You know what? I prefer the decimal. I'm going to use the decimal. 0.3085. Because we're asking for a probability, we're not asking for a percentage here. I hope that helps.